welcome. Welcome back to another episode of Game Design. Gonna be a short one today, and then I'm going to go and connect with all the teams on Discord and see what in the asset packs that I purchased might be of use to you. So I bought both of the major asset packs that were on sale this month or whatever, the Lunar New Year ones. And there are a few assets in there that I think would be useful to every team. So better to integrate them sooner than later. I'm going to go through and see what everybody might be interested in. So I've already loaded in a few here and played with them myself. You can already pick up the kinematic character controller and the melee warrior animations on Canvas. Those are both under the files, Unity, assets, something like that. And I also have enemy AI I've played around with, which will be helpful for some of you, and a bunch of others. So anyway, go check out those two asset packs. They're under asset requests in the Discord to see what you think might benefit your team, and I'll be going through talking to you to see what you might need out of those. Okie doke, let's get started on today's topic, which is enemy navigation and periodic events. So what happens when you want something to happen like once every second or once every 2 seconds or something? That kind of thing. Alright, let's talk a little bit about the setup here today. So this was me playing around with the kinematic controller and the melee warrior pack, so it took about an hour and connected those together. You can push these ragdoll cubes around while still having that character controller smoothness. You can also see the enemy AI pack in here. And then I also created a little example, I don't know what you want to call him, drone or something that chases the player, and normally he'd probably explode or something, but in this case he just runs into you and smacks you, and the little enemy guy will spawn him periodically, so a few seconds will go by and I'll make another one. Now this enemy from the enemy AI kit is really smart, and it takes a lot of energy to make an AI that's this smart. This one takes cover behind walls. It runs away from you and all that kind of good stuff. In this case, he's having a little technical difficulty finding me, I think, but he's still pretty clever. He's very capable of locating me, shooting at me. You can see his bullets actually travel in line to me. I don't know if you have the resolution for that, but you know, he kind of runs away and all that kind of stuff. So he's not completely moronic. And if you're trying to make a shooting enemy, you could just integrate this pack directly. But let's talk about how to make AI yourself. So the first step in building an AI that actually can like move around and chase the player, and also the first step if you're building any kind of intelligence that's going to move along a fixed path, so this is going to be true for tower defense games, anything where you want your AI that moves the enemies or whatever they are to avoid obstacles. The first thing you're going to do is build the navigation mesh for the scene. So this is under, what is it under? Window, AI, navigation. Okay, and once you've gotten into it once, it becomes a tab in the inspector here. You go to the navigation tab. And the first step to adding that kind of navigation into your scene is baking the Nav Mesh. The Nav Mesh is this blue surface that you see when I go into the tab. You won't have it if you haven't baked it yet. You can also uncheck showing it there. There's also the height mesh, which we might talk about later, but you probably won't need. The nav mesh is the walkable surface of your scene. So this is all of the area in the scene that enemies can walk on. If you go to agents, you'll see that you can add different presets to your scene. So I have like a humanoid here, I could add a different one. And these guys have a radius, a height, and a step height. So radius determines how wide they are, and depending on how wide they are, that affects whether or not they can fit in through, for example, this tight space here, so larger agents wouldn't be able to. Depending on how tall they are, same thing, they might not fit through certain holes. And then step height determines the slope that they can handle before they're unable to walk on it. Max slope determines the angle, and step height determines if it's just a vertical, just straight up, like a step, if they can just traverse that, or not. So if it's just straight up and is shorter than 0.075, then they can just walk on up it. If it's taller than 0.075, then it's unwalkable to them. They'll have to go around. And you can make different agents with different properties depending on how you want your different kinds of enemies or whatever to navigate the environment, but the easiest is probably just to have one agent for everything. That assumes all your enemies are roughly the same size. We're probably not going to be working with areas, but the important part here is to go to bake. If you just press bake without doing anything, it'll make you something. It probably won't be what you plan though. What you really want to do is go to object, go to your scene filter, and start adding things. So I picked the floor. Okay, the floor is navigation static. What navigation static means is that it's not going to move as the scene progresses. In Unity's navigation system, this is the main limitation to it, is that it's really difficult to move around obstacles in your scene. So if you wanted this wall to be somewhere else later in the scene, the nav mesh doesn't update as the wall moves. The nav mesh needs to be rebaked. And rebaking it is computationally expensive. It's something that you generally only do in the editor. So a game that has walls and stuff that move needs to pull off some tricks. You can't just do that right out of the box. And if that's something that you're interested in, I can show you some of those tricks. And that's true of things like doors and other stuff that you don't want enemies to be able to pass through if they're in like a closed state. Anyway, the floor is navigation static, it doesn't move, and it is walkable. You can walk on the floor. Generating off-mesh links is to connect. Let's say I had multiple floors that were not fully connected. Generating off-mesh links would allow them to be linked to one another. Alright, so then I picked all the walls. I have all my walls as objects. I just shift selected them, and I set them all to be navigation static and not walkables. Of course, you can't walk on walls. And these like ragdoll cubes and spheres and stuff that are in the scene, as well as my enemy and as well as my player, none of those things are navigation static. Those guys can move around as the scene goes on. If you're using terrain, you want to pick your terrain, you want that to be walkable probably, and so forth. How do I get out of this? Okay. Alright. Once you've picked all of those in the object menu, then you can go back to bake and hit bake, and it will generate a new nav mesh for you. I didn't change anything, so mine looks pretty much the same, but let's play around with it. Let's move, I don't know, this wall down here, and then rebake, and lo and behold, the nav mesh has changed too. That updates the walkable area for the enemies. Alright, so that's step one. Again, window AI navigation to get here, add all the walkable and unwalkable things that you want in the scene, bake it, and you're done. That was the steps that we had to go through there. Now let's make an enemy. Back to the inspector. I'm just going to use the prefab that I made because it's really dead simple. So I made this little prefab, I called him a hunter-killer, and he is a cube, a simple cube. Now, on the root of it, let's demonstrate what he does. Just going to give him a target. Watch him move towards me, lovely. When he runs into these red things, I can determine whether or not he's going to pass through them or not. Take a look at the one that I built up there, so he can push them. Alright, and that's something we'll look at in a sec. Okay, so he's a cube, but you'll notice that the mesh is not on the base level object, so all the art and stuff is on a child. This is how most of your enemies, players, etc. should be structured. You want to move the invisible top level object, all the art and stuff, make it a child. This is going to be really useful when you go back and add the art and animate. You're going to end up with like multiple meshes and stuff. So have all of your art be a child of the parent that actually does all the work and stuff. So at its most basic, I just need this Navmesh Agent added. So go to Add Component, go to Navmesh Agent, there it is. It lets me pick one of those agent types from the drop-down. That's corresponding back to these agent types that we're able to set here in the navigation menu. We can also control the height and everything of this agent, so I've set its height to be As you can see, perfectly sized to fit the cube. Likewise, I set the radius perfectly sized to fit the cube. I could have made an agent type template for this, and in fact I probably should have if I'm going to use this a lot. Now there's a couple of settings that you need to keep an eye out for. The first is priority. I don't remember if higher is better or lower is better. Lower implies higher importance. Okay. Priority determines when the AI controller invokes the Nav Mesh and tries to figure out where everybody's going to go. The stuff that's higher priority will go first, and so the lower priority an object is, once you get into having like, I don't know, dozens or hundreds of things on the Nav Mesh. First of all, dozens or hundreds of things tends to make the game run poorly. It's difficult to get that many in without a performance hit. But if you've managed to do so, one thing that you can do is prioritize the ones that are more important, like say the enemies compared to their drones, and those guys will move before others. The other thing is that quality drop down here where you can pick obstacle avoidance levels. So if I pick, I'm going to re-enable the box collider briefly. If I pick a high quality and run around, then, you know, he's going to kind of try to avoid other things in the environment that he's not supposed to hit. I don't think I actually added these red cubes to the list of things he's not supposed to hit, so in that case he's not going to bother, but you can actually make them kind of steer around other objects. I think it's best to demonstrate this by just making a ton of them next to each other. So let's see. Might have to move them a bit, but let's go. Alright, so see, they'll avoid hitting one another. They just kind of navigate around each other, and they have a lifespan of 10 seconds, by the way. That's why they disappear. If I set it to none, you'll see that they kind of hit each other, and then because I have the collider enabled on them, they can stutter away. But if I was to turn that collider off, which means that they have no physics or collision outside of the Navmesh agent, then we should see some somewhat different results, poorer results. They're still not able to phase into one another because the Navmesh agent actually prevents them from colliding with each other. Two Navmeshes can exist in the same space. It's still a collider of sorts, but they don't do that like physics when they bump into each other. All right. Oh, I'd set them all to none. I think I only set one to none. Yep, there you go. They're all inside of each other. Womp womp. So that's none and low quality. They shouldn't be inside of each other, but they should, yeah, there we go. Varying levels of stutter. So for most enemies, low quality is good enough, or none, depending on whether you care if they actually avoid like other AIs in the scene. This is actually really expensive, so setting everything to high quality, it puts a pretty substantial drain. Even setting them all to low quality is pretty draining, so just bear in mind that if you have dozens or close to like 100 of these at once, it can start to impact performance. Auto traverse off mesh link, probably irrelevant to most of you. Auto repath is the other important one. If they will acquire a new path, if their existing path goes invalid. So let's say that the player could somehow, maybe I can force this to happen, somehow move the player into non-existent space so they can no longer get to him. Darn, I can't move him without the controls. Oh well, anyway, if I could move the player into the non-existent ether, they would be very confused, but then later they would be able to reacquire him, which is tough to demonstrate. Put him back. Alright, back to other settings. Turn that back on. Yeah, that's essentially all you need to know about setting up your Navmesh agent. So let's go into the simplest way to script one to follow the player like mine is doing now. This is actually dead simple. So once you've got that Navmesh area baked, and once you've got your agent set up, all you've got to do is call agent.setDestination. Now there was a couple wrinkles here. First of all, you have to import unityengine.ai. It'll recommend this to you if you didn't when you start trying to do Navmesh Agent stuff. But if you're not familiar with Visual Studio's like quick fix, you might not have noticed that this is what it's asking you to do. So there's an extra import. I made a game object for the target. A lot of people tend to use a transform instead. That's fine too. I like to have access to the game object, but whatever, it doesn't matter. And then I made a Navmesh agent. I lock in the Navmesh agent. I am having this guy destroy itself. We'll get into what I did with the settings here a little more in a bit. And update, just straightforward, sets the destination to that player transform. So it just will continue to update its destination. If we look at the Navmesh agent component here, we see that there isn't like a destination field here. It's like a hidden thing. You don't see it in the inspector, which I always thought was a weird choice on Unity's part. But yes, it's constantly updating to wherever the player is as they move because it's an update. So this is perfectly fine. And that's basically it for an AI that runs directly at the player and kills themselves, which is what this thing is supposed to do. So you might ask, how do I make AIs that get within a certain range of the player and stop? How do I make an AI that gets to a certain position and then starts shooting and then pursues if it has to? The answer to that question is manually. And like, for example, the shooting AI, the easiest thing to do is to pick the closest point between the player and the enemy on a circle around the player that describes being in range to shoot, and set that as the destination instead of the player itself. Remember, we calculated a point on a circle like that earlier when we were doing some camera work, so you might consult there. You can also just set the destination to a random area that's within some range of the player. There are many different approaches to doing this. All of them have their upsides and downsides in terms of realism and how difficult they are to implement. But the other thing to note, and we'll borrow this from the Enemy AI package, is that most advanced kind of AI control depends on a state machine. So in the Enemy AI example, they have a finite state machine, and these are the states that it has. So it starts in... I started this one in search state, but you can start in one of the idle states. There's search state, there's wait state, there's patrol state. This particular AI also supports the ability to navigate to waypoints as part of a patrol, so it just walks back and forth. And from this example, you can see that it's pretty trivial to do that for a simple nav mesh. You can just do public game object waypoint A, and you can set the destination to A, and then if it's reached A, you set the destination to B, and then if it's reached B, you set the destination to A, and so forth. So waypoint navigation is pretty dead simple. We won't even go over it. But beyond just navigating between waypoints, this thing also has a variety of different detections. For example, if while it's patrolling, the player comes into range, then it enters another state, and then its target, rather than being the next waypoint, becomes a point near the player or something. So there's a lot of complexity to it. I'm not going to go into too much detail because every game has different AI, and there's no way to really understand what you guys want to do. Some of you don't have obstacles, some of you do, whatever, but the important thing is this, to being able to set the destination. Once you have this, you're pretty much good to go. Everything else is just logic, so bear that in mind, that this is really all the state machines do, is set the Navmesh agent to a different destination, update state, and then also do any other things that might occur, like shooting, taking cover, whatever. All of that is handled separately. This part, the navigation part, is essentially done with just this little simple script here. Now you just have to figure out where you're navigating to. Alright, let's do periodic events next. So I'm going to spawn these little cubes. I'm going to spawn these little hunter-killer cubes that I've created that just run at the player. And, I also said I was going to mention what makes them have physics or not. So if you just add a nav mesh without a rigid body and a box collider or any kind of collider, it'll work, it'll still follow the player and everything, and it won't clip through the floor. But if you wanted to be able to push around the cubes and whatnot in the environment like these guys do, so they push that cube away, then what you can do is give them a rigid body and set that rigid body to be kinematic. A kinematic rigid body can still exert physics onto other objects, but it basically doesn't have physics exerted onto itself except gravity. So kinematic rigid bodies are useful when you want an object to have realistic physics collision with another object, but you want to handle all of its movement yourself. So when I said that I got the kinematic player character controller package, you can see why this is really powerful for a main player, because you can move the character around under its own force, and you decide how it moves and everything, but it can still push cubes around, it can still have physics interactions with the environment. The problem is what happens when two kinematic rigid bodies hit each other. Well, in this case, because the player kinematic body is simulated, these cubes are actually able to push them away, which is pretty cool. But generally, two kinematic bodies pushing into each other, just nothing happening. They're just, neither of them can exert force, or neither of them can accept force. They can only exert it. So two of them, neither of them accept any force, and nothing happens. The other thing that kinematic bodies are really useful for is handling different collision events. So you can do things on collision if you have a collider and a rigid body that's kinematic attached. There's also trigger colliders. We'll go into those in more detail later. Okay, let's move on to spawning these things periodically. Okay, so I wrote this script for the enemy AI, and I wanted to also show you what it might be like to link to a script that you got from a third-party asset. So in this case, I had to link to the enemy AI's. This is the third-party asset that I got from the store. I had to link to its state package, or its state, what do you call it, class. So I have my public enemy AI state, spawn state. This is the state in which you can spawn hunter-killers, and you see I have it linked in my inspector here, just like the states that they used in their script. So note the syntax. They added their third-party package as the name state, a namespace, and then you can connect to different classes from it. I added a base spawn cooldown, and I added an isReady, so that's whether or not you're ready to spawn a new one, and then after you've spawned a new one, you should have to wait cooldown seconds before you can spawn a new one again. And then these, just ignore for now. We're going to go into those in more detail later. So, at the start, I linked to that state controller script from the third-party package that's attached to this enemy. I link to the settings thing that we're going to gloss over for now. I get how many seconds it is for the spawn. The spawning should be pretty straightforward to you at this point. If this guy is ready to spawn, and if the AI controller is attacking, so the spawn state that I'm looking for is the attack state. So if the dude is in the attack state, then he's ready to spawn one of these things. Again, you see how state management here is useful. I don't have to check any other conditions, right? I don't have to check that the dude is within distance again. I don't have to check that the player is visible. All of that stuff was done for me in the state manager. And if you're writing this manually, again, you would do the same thing. If the enemy is ready to attack, he moves into the attack state, and then all the other scripts can just check, is he in the attack state? If yes, then I can do all the crap that I want to do. Okay, so if he's in the attack state and he's ready to spawn something, I spawn a thing. Then I link to its nav to player script. That's this guy, remember? And then I'm just updating his destination, that player object, to my aim target, which comes again from that state controller third-party script. That's the aim target, is the player that he's shooting at. Now you're no longer ready. And now here's where the periodic event comes in. So there's two ways to do something not on every update. Okay. Well, there's three, but there's two main ways to do it. There's invoke repeating, and there's coroutines. And of the two, I would say 90% of the time, go with coroutines. I go with coroutines all the time. If you don't learn invoke repeating at all, that's fine. You don't need it. Coroutines can do everything invoke repeating can. So a coroutine starts like this. You say start coroutine, you say the name of it. The function has this syntax. It's weird. It doesn't have public. It doesn't have void. It has IE numerator. Coroutines are always voids. They don't return anything. They can't. Coroutines always have a name like that. They don't have arguments. There's some exceptions to this. You can give them arguments, but generally you want to just pass them in from global state somehow. We'll talk a little bit about the cost of starting a coroutine. Every time you start one, it invokes a small memory cost. The more local variables that it has, like a equals 5, the higher that memory cost is. That means that you want to start coroutines rarely. If you start a coroutine every frame, so if it's inside of update like this, and I didn't have this if condition that made it happen rarely, you would blow up your performance almost instantly. But you can start 100 coroutines a second, no problem. And more importantly, you can have 1,000, maybe even more, like 10,000 coroutines running or waiting to run at any given point with almost no burden except a little bit of memory, which is usually pretty abundant on computers. So, small memory upkeep. What does the coroutine do? The coroutine schedules this task to be run. If I didn't have this line here, which we'll go over later, then it would just do its business and close up. If you want a coroutine to stop, though, stop coroutine, whatever its name is, we'll kill it. Alright. You can also exit with yield return null, I want to say, or yield return break. Break null, something like that. Anyway, yield return null exits. Alright. But let's look at what I did here, which was a little bit different. I said yield return new, wait for seconds, base spawn cooldown. So what yield return new wait for seconds does, and there's another option here that's similar, that's yield return new wait for seconds real time, and then some other ones that you might use at some point is wait for end of frame and wait for fixed update. These I tend to avoid because it's better to just do the thing in post update or in fixed update. You don't really generally have much use for these. What this does is it will just pause for that number of seconds and then it will run the rest of the code. So it basically queues up the rest of this code to run after that many seconds have expired. So to make a periodic event, let's say you want to make something that happens every second, like a cooldown ticking down. Well, just have your coroutine bundled inside of while true, yield return, wait for seconds, 1 second, and then do the thing that you're going to do. Forgot the word do. And then just do the thing you want to do once per second. Now you're doing it once per second instead of doing it every update. And now update doesn't have to check. It doesn't have to even have an if condition or anything. It just will awaken this thing every second and do it. And this is a low overhead and highly performant way to do things periodically. Okay, so what do you not want to do with coroutines? Well, if your time is really, really small, the wait time is like 0.01 second, just do it in update because the overhead becomes not worth it at that point. If you're starting coroutines really often, more than like once a second, don't do it, just do it in update. But anything that's happening periodically or anything that happens after a delay, you should always pull for coroutines first. So in this case, I have something happening after a delay. IsReady is set to false. And then in the logic of this game, it's impossible for it to be set back to true unless the cooldown expires. That's important here because if the logic gave me another avenue for resetting it, then this would be kind of buggy because this coroutine could trigger to true, and I might have started another one. I could start another copy of it again. Okay, so if I had some other way to set IsReady back to true, then this could fire again and start another coroutine that's setting it back to true, and then I'd have a conflict. But in this situation, the logic is simple enough that all I want to do is wait the number of seconds for the cooldown to elapse, and I want to set as ready to true, and then my dude can spawn another hunter killer or whatever. So this is one of the more common applications, and then the next most common is probably for something that happens like every second. Again, just bind that inside of a while true. And if I really wanted to do this correctly, I think I would have to do the return null there. Alright, any questions on coroutines? This is a broad topic that encapsulates all periodic events. Many of you have periodic events in mind, cooldowns that have to tick, health that has to regenerate, enemies that have to spawn. All of this stuff should happen inside of a coroutine. So feel free to hit me with more specific questions. I'll show you more specific examples of coroutines, and there's also a ton that you can look at in the different examples that I've given you. Alright, let's look at what I did with the settings, and I'll explain to you why I feel like you should copy this. So there are two approaches for settings that I like. So these are things that you might tweak for the entire game. So like my enemies spawn these hunter-killer drones, they have a certain lifespan. I don't want to be going to different prefabs across my game in different scenes or whatever and editing all these different elements of them. I want a single common place where I can edit all of the different settings in the game. This is really useful for if you pick up like a power-up or something, or if you pick up some kind of power down, or if the game increases in difficulty. These values change, and they change across multiple different prefabs. Like maybe I have many, many different kinds of enemies, and I like them all to have a single common source of truth. And so what I've built here is a singleton, which should be a concept that you've learned in your other classes, but notice that I've erased mono behavior from the description. So this is a class but not a mono behavior. This is just a script. It doesn't have a start or an update. It just has this get instance method. It has an instance. And if you want to talk to the settings, if you want to query a setting or update it, realistically these should be private, and I should have a way to update them and a way to get them and whatever. This is just a really simple example, but if you want to talk to the settings, you just invoke get instance and then look at whatever setting you want. So in the hunter-killer example here, I connected to the settings with get instance. What happens when you call get instance? Well, if it doesn't exist yet, if the settings don't exist, then it makes a new one. And these are all the defaults that it starts with. Whereas if it does exist already, so it's not null, then it just returns the instance that you have running now. So when you build a scene, the very first script that calls get instance will build the new enemy settings. And then from there on, you can make all the tweaks and changes that you need to convert the settings to whatever that scene has to be. I don't know, maybe drones are faster in that scene, maybe they last longer, whatever. And then for the rest of the scene, you just have access to those settings from any script, and you don't have to store, like, okay, I have my, imagine if I stored my hunter-killer spawn interval and lifespan on my hunter-killer script, then I have to change it, then I have to go back to that particular script and figure out where it is, and it's a pain. Have all of the settings that you possibly can in a single central location, like so. Okay, that's option one for doing it, was doing it like this in a script with a singleton. Option two, which I see many tutorials and stuff prefer, I think Unity vastly prefers this approach too, is to have an empty game object called like your enemy settings or something, and attach the mono behavior to that, and make sure that you just have only one of those per scene. That can easily be done manually. You can even take the same approach like this, and anytime the scene is created, if there's no enemy settings object spawned, you can spawn one in the script. Then you have your script attached to it, and instead of get instance, what all the objects in the scene that want to reference it can do is they can do a find command. So they can do find object by name or find object of type, and then they can just quickly have access to it that way. I prefer the singleton approach because the call to get instance is virtually free. It's near instantaneous, doesn't require any finding. In practice, the find command, when everything in the scene does it, becomes relatively cheap because of caching effects, but to me, the Singleton thing makes more sense. The downside to the Singleton approach is that it's difficult to manage your state. Like, if multiple different scripts have to update the lifespan for the whole scene globally, it can be easy to lose track. But if these are settings that rarely change, or are just preset at the start of a scene, then I find this to be perfectly acceptable. And of course, the other big downside is that, as this is not a mono behavior, I can't just drag this into my enemy settings here and play around with it on a per scene basis. I have to make all of my tweaks in script, which is a little bit annoying. So up to you how you want to do it. A single object with a script that everybody can reference, usually with its own layer or tag, or a singleton like this, where all the settings are. But I strongly encourage you to put all of your settings into one script. You can differentiate these, like have one for enemy settings, one for player settings, one for physics settings, etc. But it's nice to have a single common point where you can affect multiple different changes for multiple different objects in your scene at once. Alright, I think that's all the important things I was going to cover today. So I bought all of those assets. What I'm going to go through today with all the teams again and see what you need. Try to get you started with some of those store assets. So just look through those 2 packs and let me know what you think you might need. And I was very hand-wavy about the scripts today, so if there's any other examples you want to see of coroutines or navigation, let me know and I will make a snippet for you. Alright, cool. I will see you in Discord.